What specialized coatings manage radiation in spacecraft heat transfer? Imagine trying to keep a spacecraft cool or warm in the vast emptiness of space. Without air or water to help, managing heat becomes a real challenge. That's where special coatings come into play. These coatings are like the spacecraft's wardrobe, helping it reflect, absorb, or emit heat just right. Since space is a vacuum, radiation is the main way heat moves around. So, engineers design coatings that control this radiation to keep spacecraft safe and functioning. One type of coating used is called thermal control coatings. These are applied directly to the spacecraft's surface. They have two main features: how much solar radiation they absorb and how well they emit infrared radiation. White coatings with high reflectivity and high emissivity are common. They bounce sunlight away and radiate internal heat out into space, keeping things cool. Black coatings, on the other hand, absorb heat very well and radiate it efficiently, which helps in heating or balancing temperatures inside the spacecraft. Another important coating is called multi-layer insulation. Think of it as a sandwich of thin reflective films, often made from aluminized mylar or captain. These layers are separated by tiny spacers to prevent heat from passing through by radiation. The outer layers block sunlight and are tough enough to withstand space conditions. The inner layers have low emissivity, meaning they don't radiate heat easily, helping to keep the spacecraft warm or cool as needed. Sometimes, hybrid coatings are used. These combine reflective metals like aluminum with non-reflective materials such as ceramics or polymers. The metal layer reflects solar heat, while the non-reflective layer limits heat radiation from the spacecraft. This balance helps in managing temperatures more precisely. Aerogels are another fascinating material. They are extremely light and porous, trapping air inside their structure. This makes them excellent insulators, reducing heat transfer by both conduction and radiation. Aerogels have been used on space missions like the Hubble Space Telescope and Mars rovers to protect against extreme temperature swings. Radiator coatings are also key. They often involve special reflective surfaces like second surface silver on fluorinated ethylene propylene tapes. These coatings reflected sunlight while allowing the spacecraft to emit infrared heat efficiently. This helps radiators stay effective at rejecting unwanted heat. Choosing the right coating depends on the spacecraft's mission. For example, a satellite near the sun needs coatings with low solar absorption and high infrared emission to avoid overheating. Conversely, a spacecraft in colder regions might use coatings that absorb more heat to stay warm. In simple terms, managing radiation in spacecraft heat transfer involves coatings that reflected sunlight, emit infrared heat, or insulate parts of the spacecraft. Whether it's white paint, multi-layer blankets, hybrid coatings, or aerogels, each plays a role in keeping the spacecraft within safe temperature limits. These coatings are carefully selected based on the mission's environment and thermal needs, making sure the spacecraft can operate smoothly in the harsh conditions of space.